Hello my dear students, we will continue with Newton's laws of motion, and under the three laws of motion we are going to cover Newton's second law of motion in today's class. Alright, under which we are going to learn these things. Firstly, we will learn the statement of Newton's second law of motion. Alright, then we will see, after learning the statement, cause and effect. Okay, cause and effect with relation to the force. Okay, what is the cause, what is the effect? All right, then we will learn mathematical form of Newton's second law. We will just learn the mathematical form of Newton's second law of motion. We are not going to derive it. All right, then we will see how mass is related to inertia of a body. Okay, then we will learn the various units of force. So these are the things which we are going to cover in today's class. Let's begin with the statement of Newton's second law of motion. Now, when we were learning Newton's first law of motion, we came to learn about the new term. Okay, two new terms were learned in Newton's first law of motion. We learned about inertia and then we learned about force. So, Newton's first law, we got the concept of force. Alright, now in Newton's second law, what we are going to learn is that we are going to see the effect of force. What happens when you apply force on a body? What will happen to the object? Alright, after a force is applied on the body. Alright, so first law is basically giving you the concept of force and second law is basically giving you the effect of force or the use of force. So let me give you the statement of Newton's second law of motion. It states that acceleration of an object is directly proportional or related. Acceleration of a body is directly proportional to force applied. So this is the simplest statement of Newton's second law of motion. There are other ways in which we can state Newton's second law of motion, but to get a concept about Newton's second law, this is the simplest statement that we can give. Okay, so Newton's second law of motion states that the acceleration of a body or of an object is directly proportional to the force applied, in addition to which we can also state that it is inversely proportional to the object's mass. So we can write it is inversely proportional to its mass. So in total we can in a gist we can state Newton's second law as acceleration of an object is directly proportional to the force applied and inversely proportional to the mass of the object. Alright, that means if you apply a force on a body, the body will accelerate. Alright, that means velocity of the body is going to change. For example, you kick a ball which is initially at rest. So you have a ball, alright, you have a ball which is initially at rest. Means initial velocity, that is u. If you remember the previous classes, we denote it by u, small u. Initial velocity of the body is equal to 0. There is a ball. Okay, now you kick the ball. Kick means, kick is a kind of force. You are applying a force on the ball. Now the ball will start rolling. It will start moving. So say the final velocity is v. Now initially the body was at rest, the ball was at rest, initial velocity is 0, and when you apply a force on a ball, that means kick is a kind of force you apply on the body will start moving with a certain higher value of velocity. That means velocity has changed from a lower value to a final value to a higher value. That means the ball has been accelerated. Now, why has the ball accelerated? Because you have applied a force on the ball, or you have kicked the ball. Okay. So, you apply a force on a body, acceleration will occur. You kick it with more force, the final velocity will be even higher. That means acceleration will be even higher. It means that acceleration is directly proportional to the applied force. This is how we state Newton's second law mathematically. Alright, or we can say force is directly proportional to acceleration. Okay, so this is what happens when you apply force on a body. The body will accelerate. Now, what has made the ball accelerate? It is the force. So, why? So, force, it is the cause. What has made the ball accelerate? It is the force that has made the ball accelerate. So, force becomes the cause. Okay. And because we have applied a force, we are able to get an acceleration, which is nothing but an effect of force. Okay, so had there been no force applied on the ball, there would not be any acceleration. So without force, acceleration was not possible. So acceleration happens to be an effect of force. So acceleration is the effect. That is why we say that force is the cause, acceleration is the effect. All right, now talking about acceleration, if the ball is a normal football which is hollow inside, okay, which is hollow inside, you will not be required to apply that much of force. Okay, simply it will start accelerating. But if you want to kick a ball which is made of iron, will it accelerate? You apply the same amount of force on a normal football. Okay, you apply a kick and you have a ball made of iron which is quite heavy. Apply the same amount of force. Okay, now which one will go farther and faster? Will this iron ball be able to go as far as the football here? No, it is not possible, because its mass is less. Okay, mass less means acceleration will be more, and here mass is more, but acceleration produced will not be that much, so acceleration is less. That means mass, acceleration, they are not directly proportional to each other, they are inversely proportional to each other. Okay, no matter you apply the same force on both the balls, but because of mass, okay, there is something called inertia also in it. Because of mass, it is not able, they are not able to get accelerated to the same amount, they are getting accelerated to different amounts. Okay, that is why we say that acceleration is inversely proportional to mass. So acceleration is 1 by proportional to 1 by m, means acceleration is inversely proportional to mass. And the first part of the statement was stating that acceleration is directly proportional to force. All right, now what happens? We can combine these two equations to get an equation. So left hand side is the same. This is called combining equations. Left hand side is the same, is proportional to, we just have to multiply both the things which are lying on the right hand side of both the equations. So relations, we can call it equation, F into 1 by m. Okay, now cross multiply. Now we can remove the sign of proportionality. A is equal to F into 1 by m. All right, or this will go up, m into A is equal to F, or just flipping sides, we get the mathematical form or the postulate of Newton's second law, that is F is equal to mass into acceleration. I box it, means it is important. Okay, so this is the mathematical form of Newton's second law. What is the mathematical form of Newton's second law? Force is equal to mass multiplied by acceleration. Here m means mass and a means acceleration. All right, you have to keep this in mind. Okay. Now from this mathematical statement, this m plays, you can see that this m or the mass plays a very important role in an object that is accelerating because of a force. All right, so mass happens to be an intrinsic property of an object which is subject to a force which is getting accelerated. Okay, now this mass also determines the inertial resistance of a body. In the last class, when we were doing Newton's first law of motion, we learned about inertia, and we also learned that mass and inertia are related. Okay, how are they related? Mass and inertia are directly proportional to each other. So mass, or rather I should say inertia, how does it depend upon mass? It is directly proportional to mass. Okay, so a heavier mass will have more inertia, more resistance, more inertial resistance. A lighter mass or a lighter object with less mass will have less inertial resistance. That is what Newton's second law tells us about the relationship between inertia and mass. All right. Okay, since we have learned the concept of force and we have also learned the effect of force, let us now learn the units of force. In which unit are we going to measure this force? We should have a unit to measure a physical quantity, right? So what are the units we use in our day-to-day life, in practical life, to measure force? Okay, now I will just take two systems of unit as prescribed in the syllabus for you. In CGS system, the unit of force is dyne. dyne. Dyne is the unit, CGS unit of force. Okay, and in SI system, that is the accepted, internationally accepted system, it is Newton. Symbol is capital N. Okay, so we measure force in terms, if the force is a small value, then we go for dyne, and if the force's value is huge, and if you want to go for standard units, then you have to use Newton, named after the scientist Sir Isaac Newton. Okay, now let us define how much 1 dyne is and how much 1 Newton is. All right. Now, if you want to define a unit, then you have to use the formula. The unit which we are talking about is force. So we will use the formula for force, which is from Newton's second law, M into A. Okay. Now, if you take the CGS system, unit of force is dyne. Replace each term in the formula by the respective units. Unit of mass in CGS system is gram. Okay, and unit of acceleration in CGS system is centimeter per second square. Okay, so if you want to define 1 dyne, Now on the right hand side we have to make it 1. So 1 into 1 will be 1. So we'll just put 1 in front of gram also and 1 in front of centimeter per second square also. So 1 dyne is the force which when applied on a mass of 1 gram produces an acceleration of 1 centimeter per second square in the body. So how much is 1 dyne equal to? 1 dyne is the amount of force if you apply 1 dyne to an object whose mass is exactly 1 gram, and if the object starts rolling or starts moving with an acceleration of 1 centimeter per second square, then we can say that we have applied a force of 1 dyne on the body. Okay. Similarly, we go to SI unit, SI system. For force, SI unit of force is Newton. Okay, we use capital N. M unit of mass is kilogram, and unit of acceleration is meter per second square. So if you want to find out 1, then we have to multiply 1 everywhere. So 1 Newton is equal to 1 kilogram into 1 meter per second square. So how much is 1 Newton equal to, or how do you define 1 Newton force? 1 Newton is the force which when applied on a mass of 1 kg produces an acceleration of 1 meter per second square in it. Okay, very simple. We start with the formula, replace each term in the formula by the respective unit, then we take 1 in each case. Okay, take the unit quantity of each case, and then we can easily define the various units. All right, so these are the 2 units of force. Of course, there are other units in gravitational units. Okay, we are not doing that because the standard units of forces are dyne and Newton. Okay, lastly, we will also find out what is the relationship between Newton and dyne. Alright, so we will find the relationship between Newton and dyne. So, 1 Newton is equal to 1 kilogram multiplied by 1 meter per second square. Alright, now we will convert everything into the smaller system of unit, that is CGS. We will convert kilogram into gram and meter into centimeter, need not convert second here. Alright. So 1 kg, it is equal to 1000 gram into, 1 meter is 100 centimeter. Centimeter per second square. Let me make it clear for you. Into 100, instead of meter I write centimeter per second square. Alright. Now 1, 2, 3, 4, 5 zeros. Let's write them together. Gram centimeter per second square. Now what is this gram centimeter per second square? It is nothing but dyne. So we started with Newton and arrived at dyne. So 1 Newton is equal to how many dyne? If you write it in exponents, 10 to the power, there are 5 zeros, so 10 to the power 5 dyne. This is the relationship between the SI unit and CGS unit of force. 1 Newton is equal to 10 to the power 5 dyne. Alright, so we'll stop here for today's class. Let me give you a brief revision of what we have done. Firstly, we defined Newton's second law of motion. We stated Newton's second law of motion in terms of acceleration and mass of a body. We also stated Newton's second law of motion mathematically, where the statement was F is equal to m into A. Okay, and we also learned that force is the cause and acceleration is the effect for a body. We also learned that mass is an intrinsic property of a body. It determines the inertial resistance of a body. Alright. Lastly, we stopped the class with learning the 2 units of force. Firstly, in the CGS system, which is dyne. Secondly, in the SI system, that is Newton. And then we also established a relationship between Newton and dyne, where 1 Newton is equal to 10 to the power 5 dyne. Alright, that is all for today's class. See you all in the next class.